This is the QuickField example of transient heat transfer temperature response of a suddenly cooled wire. Detailed information regarding this problem is available on the web page of this problem at quickfield.com. So here we have a task. We should determine the temperature of a copper wire after sudden cooling. This temperature will alternate with the time. Here we have a geometrical model with geometrical parameters and log properties and boundary conditions. All of these parameters are listed here. And our task, as I said before, is to determine the temperature in the wire. Now let's go to QuickField and to create this problem from scratch. I choose new problem. Press next. This is the transient heat transfer problem. The model class is plane parallel, length units, inches, coordinate system, Cartesian, and normal precision. Now we should set timing parameters. We will calculate up to 186 seconds, that is up to 3 minutes, with a step of 4.5 seconds. And also we will store the results every 9 seconds. Now we can finish. Now let's create geometry of this problem. The model presents a quarter arc. So first let's add 2 vertices. I can add vertices this way. I just put the coordinates manually. And I can zoom to fit. Now I choose quarter arc. And I connect these 2 vertices by this arc. Now I select straight line. Okay, now the geometry is done. The next step is to assign the labels to the blocks. I choose this block and select properties. We will call it the wire. Then I assign labels to the edges. Sorry. I select this arc and do the same operation. We will call it conv, that is convection. After that, I select these two edges, and I call them symmetry. Okay, now let's set the parameters to these labels. The channel conductivity of the copper is 380. Channel capacity is 16, and the density is about 9,000. Okay. Now we can build the mesh. So the meshing is done. And then we set edge labels properties. And for symmetry, I just select a zero heat flux boundary condition. And now we should calculate initial conditions. In order to calculate initial conditions, I should create another problem. In the same folder where I stored the transient heat transfer problem. The problem type is steady state heat transfer, and I just should select the same geometry file here. Now we should just a little bit adjust the top label parameters. At first I change the general conductivity of the wire, and I change boundary conditions as well. At first, convection boundary conditions. And the symmetry boundary condition remain the same. Now I should solve this problem. And this. Solution is done. Now I get back to the transient heat transfer problem, and now I can make a linkage between the transient heat transfer problem and the problem of steady state heat transfer that contain information regarding the initial temperature distribution. So I select temperature field and I add the problem of steady state heat transfer as a data source. The time has been already adjusted, so now we can solve the problem. Solution is done. Now let's take a look at the results. This is the temperature field. The distribution is for sure homogeneous, and we are interested in the dependence of the temperature from the time. I select the wire block and choose time plot, and now I get the time plot for the temperature. This is how the temperature depends on the time. This is the same plot that we have on the QuickField.com, and also here we have a comparison of QuickField results with reference and ANSYS software. One can see that the results matches one another.